Chapter 9, Section 9.1, Statistic. Inferences from two samples. So in Chapter 8, we deal with only one populations, but here we deal with two populations in these chapters. Now, let's start with one example here. Basically, what we do here, we want to claim and compare two populations. Let's assume there are two populations and we want to talk about the mean value of ages on these two populations. Population number one, let's assume there are three people here. Their ages are 25, 30, and 50. So when we calculate the mean, which you just add all these three numbers divided by 3, the mean happened to be 35. The second population, there are 6 people in it, and these are their ages. So for that one, when we calculate the mean, which we add all these numbers and divide by 6, we happen to have the same mean value, 35. So you see, both have the same value for the mean. So in that case, we could claim that mean of populations, the first one is equal to mean of population, second one, or the difference is 0. See, in this chapter, instead of using the claim as mean 1 equal mean 2, we always use the difference. It's like if you have two numbers, let's say 7 equal to 7, then you could say 7 minus 7 is 0. All right, so one of the claim is when the difference is 0. Then let's look at the second example. The second examples, I did calculation for two different populations. One population, there are 3 numbers in it, and when I calculate the mean, it's 39. The second population, there are 4 numbers in it. When I calculate the mean, it's 30. So you notice that the first population mean is greater than the first one. See, 39 and 30. So we could actually claim that mean of age in the first population is greater than mean of age in the second population, or the difference is greater than 0. See, like if you have two numbers, let's say 10 is greater than 3. And if you move 3 to the other side, that means 7 is greater than 0. So the difference is always greater than 0. So that's how you claim. So if the first population's mean is greater than the second population, then your claim is the difference is always greater than 0, is a positive number. The third example is that when we count, there are 4 ages here, 4 people in the first population, mean is 21, 29, and the second one, there are 3 people with these ages and mean is 30. So in this example, you notice that the mean in the first one is less than the mean in the second one, see? So that means the difference is always less than 0. So you have one of these 3 scenarios, is either the difference of mean is less than 0, difference of mean is greater than 0, or difference of the mean is equal to 0 or not equal to 0. And then you understand that if the difference is less than 0, which is normally for H1, then it's left tail. If the difference of proportion is greater than 0, which again, this is a case also for H1, because H1 determined the curve. So it would be right tail, or if the difference is equal to 0 or not equal to 0, we are using 2 tails, okay? So again, if the difference is equal or not equal, we always use 2 tails on the graph. If the difference is always greater than 0, we use the right tail, and if the difference is less than 0, we use left tails. Now the formulas, we have all these different formulas that we are using for 2 populations, and these are the formula for calculation of the Z and the confidence interval. And we look at this formula when we go to the examples. And And this is a formula that we use for confidence interval. You see that the difference of population proportion is when you take the sample, proportion of the sample number 1, proportion of sample 2, and this is the margin of the error, okay? So let's look at this example. We have this example that here, there are two population. One is population of the state of Connecticut, and then second is population of the state of New York. So there are two numbers are given. On the first one, they're saying that, and you have a copy of this, I already put a copy of this on the cameras, right? So on the first one, they're saying that proportion of the first one, X1 is 239 and N1 is 2049. That's for Connecticut. And then for New York, the X2 is 9 and N2 is 550. So these informations are given, okay? Now, and alpha is 5%, significance level is given is 5%. Now, first you need to check the requirement. What is the requirement? The requirement is the samples are always has to be random samples, which normally that's the case for all the problems. Number two, two samples are independent because cars in the samples are not matched or paired in any way. See, we are talking about two different states. And you want to make sure that when you take N and multiply by P, or N multiplied by Q is always greater than 5. So that means here, when you calculate the proportions, proportion is given in the problems because what is a proportion? Like P hat is X1 over N1 or 239 over 2049. And that also has been calculated for you here. One is 0.12, one is 0.02, okay? So this is P1 and this is P2. All right, so, and then you take that and here, original claim. So original claim is, they are saying that the difference is 0, or they are saying that their proportions is always equal, okay? Since HO always take equality sign, P1 is equal to P2 is your HO, and P1 not equal to P2 is your H1. Null hypothesis, alternate hypothesis. The formula is this. This part in the formula is always 0. So it's just proportion of first population minus proportion of the second population divided by all this. What is P bar and Q bar? P bar is that coming from this formula. You have the X bar and X2, you put all this here. You have N1 and N2. See? So this X1 and X2 are these two numbers. So that gives you the P hat or P bar. P bar then subtracted from 1 to find Q bar. You take all this and plug into this formula. Then you have 7.11 as your Z value. Now, since significance level alpha is 5%, and we know we have two tails. If you want to use a calculator to find the Z, you go to second verse and then inverse norm, and then you put this area one tail, which is 0.025. Calculator would give you Z value of minus 1.96 and 1.96. Now 7.11, where does that fall? Does it fall into the critical area? Yes, because 1.96 is here, so 7 falls somewhere here. In the critical, when we fall into the critical area, we always reject HO and accept H1, which means we accept that. So we say no, populations are not equal. They're not equal. And you should always try also the p-value method, and p-value method must match traditional method. These two must always match. When I use my calculator, p-value would be 0, and that is less than 5%. So if the p-value is less than 5%, then we also reject HO and accept H1. And when I go to the calculator, I'll show you how to come up with these numbers, okay? And then we also have a confidence interval. The formula for the confidence interval is this. You have all these values. You have all this value you input here to find your margin of error. Then you take the margin of error and you have P1 minus P2. We already have these two numbers here. That gives you the confidence interval, which is from 0.082 to 0.018. So if the 0 is here, 0.082 and 0.118, see? The interval, confidence interval show these areas. So 0 doesn't fall into it, okay? So that means P1 minus P2, P1 minus P2 equals 0 does not fall into the confidence interval. P1 minus P2 is equal to 0 does not fall here. P1 minus P2 is 0.118 and or between 0.082. So the confidence interval limit do not contain 0, suggesting that there is a significant difference between the two proportions, or Connecticut and New York do not have the same proportion of the cars with the real license plates, okay? So now I want to show you how to use the calculator to come up with these numbers here. On the first one, first, we want to calculate what we have here. You see how we came up with this z equals 7.11? We want to verify that. So on your calculator, you put stat test2 and then you go to 2 proportion z test. Number 6, 2 proportion z test. You input the information. You put x1 is 239, n1 is 2049, n2, x2 and n2, and then you pick this one because original claim of h1 is not equal, right? So you pick that. And then you calculate. That gives you the z equal 7.10. And also remember that p was 0, almost 0. Look, the value of the p-value that we compare with significance level is 1.19 times 10 to the power of minus 12. Is almost 0. The p-value is 0. This is the p-value that we refer in this part. See that here? P-value from the calculator is almost 0. If the p-value from the calculator is less than alpha, then we reject HO. Where will we get this for 0? From here. Okay, so that's how to calculate the z value. Now, how do we calculate the confidence interval? To calculate the confidence interval, you go to stat, test again. And now 2 proportion z interval, let's find that one. Two proportion z interval, which is the b. And you could always tell when you enter space, okay, see, x1, n1, since you calculate, use the calculator to find the z, information is already there. We don't have to do anything. It's just, you need to find this confidence level, you got to put this 90.95. Remember 0.95, if you, the problem is two tails, right? See, it's two tails and significance level is 0.05. Significance level is 0.05 and you have two tail tests. So in that case, confidence level is 0.95. So that's where you put this 0.95 here. And then you calculate. That gives you the numbers 0.001178 and 0.082. You find it from here. Okay? So that end of section 9.1.